Good morning, everyone. So, welcome to this series, and this series will be somehow like about my view or like my feeling about like how I memorize like mathematical objects or like my like I love like different kinds of stories and like weird stuffs. So this will be kind of like a complementary way to understand like linear algebra, I would say. So prerequisite, you need to learn all the materials in the correct way at least once. Okay, so if this is your first time get in touch with this, it's fine. But after that, you need to really understand in the context of like a formal way, or else your memorizing your memory will be ruined. And second is like you really need to be willing to accept some weird but probably interesting concepts. Okay, so I'll use a different type of method. I try to make it as in like a story instead of like as in heavy mathematical things. So but you need to know that since I'm doing it in a story way, so there will be some exceptions. It's like always like this. Mathematics is full of definitions, and definitions are so rigid that when you are trying to use your imagination, there will be some exceptions. So you need to be careful of that. Topics to cover. So first of all, it's like a row operations, row echelon form, and like a reduced row echelon form. Second is coordinates, linear independence, spanning, and basis. Three is like a subspace, image and kernel of a linear transformation, and a regular theorem. And finally, eigenvectors, eigenvalues, and eigenspaces. So if you know all the concepts by your heart already, so you know how to write down the definition, know how to deal with all the things, then you probably don't need to watch this video, I'll say. But otherwise, please stay with me, and I will try to explain to you how I feel about these. So row operation. I'm not sure whether you have played Minecraft or not. So this thing is a monster which can spits fire in front of itself, in some sense. Okay. So in fact to say about a row operation, I always think about blazes. This is called blazes. Okay, and it has a very weird look. I know, but yeah. Okay. So let's do an example. Yeah, it's better to do an example and then to show you how I understand this by these kind of places. Okay, so reduce the following matrix into REF. Okay, so how are we going to do this? The point here is that like what you want to do is you want to find a place. You want to find a place in the leftmost column. Okay, you want to find a place in leftmost column. What I'm meaning with that? Okay, so you see here you have the leftmost column, and you're finding a one or minus one. Okay, so one or minus one, because they look like a place, so we choose it. I mean, there's other reasons, of course, but this is I claim is a reason that we choose it. Okay, and we usually choose a minus one as one, okay, because you just add a minus sign. And if there's no obvious choice, then you need to divide. So you need to make one of them turn it into place. But yeah, it is more a computationally heavy. Okay, so what do you do about this place? What we're going to do is we're going to change the whole row to the first row. Okay, so you're going to change the whole row. Okay, so first you need to change it into place, so you need to change it into plus one. Okay, it was minus one, right? So you remember when you are doing this, you need to change all the signs. Okay, and then now you shift it to the top, so you exchange these two rows, so you can see it becomes here. And why I use the word place is that you're going to grill. You're going to grill. So this monster is going to grill these two things. Okay. So let's see. So this was two, right? So what you do is you are going to subtract two times of row one. So make it to be zero. You just screw it to nothing. And here is five, right? This five, you do minus five times of row one. You just screw it to nothing. There's nothing to think. Okay? So you make a place. You find a place. You probably need to have minus one, or you need to have a divide, and then you move it to the top. Then you just screw. Okay? So the step is like this: find, move it to the top, and then you just kill all things below. Okay. Okay, so now what is the next step? Next step is the same. You just find the potential place. But now since we have finished this column, and by finishing this column, because this is a place, and we will also say that this row is finished. Okay, so you just ignore these two columns and rows. So what is the next step? You just find the leftmost column, but it's the remaining leftmost column. You can't use this because it's grayed already. So you need to find a place. Here the place is definitely the -1 because it looks like 1 and it looks like the place, right? So what you do, you make it into place by adding minus sign, and then you grill. Okay, so you look at this, there's something below, you just grill. Yep. Okay. By the way, by grilling, I mean that it was 3, right? This 3 is being the subtracted, so you make it into 0. Okay. So what is the next step? Same thing, right? You're doing the same thing, but now you have two places. So here is a place, here is a place, okay? And now, what is remaining? You look at this column, so you need to make it in a place because you have no choice. Now, 33, you have no better choice, so you need to choose it and turn it into place. And now this thing, turn to place, is divided by 33, right? And do you have anything to glue? Look at here. You want to glue anything below, but there's nothing, right? There's nothing. So that's why we just there's nothing to grow. So the step 1 ends because all rows are being done. So all rows, all columns are being done. So this thing is called REF. Okay, REF. So this a structure. You can see the places are lining up in this kind of context. And that there could be some numbers up there, and this is called REF. Okay. So what is REF then? REF is very similar. So what you do is so I said that the place is screwing something below, right? So what we're going to do is we choose so we're starting from left to right, right? It was where we started, and now we are going to do in reverse order. So we're going to do from right to left. So you start from the rightmost place, and then you glue all the things above. Glue all the things above. Okay, you just make it into 0 and 0. Okay, and you just by the way, for example, if you cancel this -2, you just add 2 copy. If you cancel this -8, you just add 8 copies. Okay, so it's not big deal. Okay, and now what you do next is okay, so now you look at this thing is grilled, and you look at the second place. This second place will kill. You want to kill this thing, right? By probably adding a row. And voila, you can see that here you have the all ones, and all the things above are grilled, all the things below are grilled. Okay, so there's nothing in the row of the place, so it's called REF. Okay, so this is called REF. Let me see what is here. Okay, so conclusion of I need to write down is REF. Okay, so conclusion. Conclusion is step 1A, you want to find a potential place in the leftmost column. Okay, so you ignore the rows and columns repeated. As 1B is that you find you bring the base place to the top and then glue everything below. Okay, you remember it's below. So you first start the matrix is like this. You start from left to right. You find a place. You glue things below. You find a place. You glue things below, you find a place, you glue things below, okay? So this is always like this. So this is step 1B. So you repeat the step 1A and 1B until there's nothing else to do, okay? And the second step is so now your matrix should look something like this. And then you could have a 3, 4, 5, 6, 7, 8. So, you can have many different breaks. So you start from rightmost and then you grow above. Start from rightmost, you grow above. Start from rightmost, you grow above. Okay, so this is how you are going to do. So remarks, you remember -1 is also 1 because adding minus sign is very easy. If there's no ones, no. Okay, by the way, the place is called the leading one. Okay, Yeah, if you like heard the word leading one, it just means place. If you don't have a one in column, you just by definition you make it one of them in the place. If there is a zero column, so for example, if you have like a 100 000, and then like a 345, okay. So this column is ignored. You just like don't like you just pretend it's completed, and then you start from this column. And by the way, like this is a place, so it's completed like this. It's completed. So the like this is a remaining column. So you choose the 4 or 5. Okay. Okay. So I hope that this place is going to like help you to memorize like what is like what needs to be done in row operations. Okay. Okay, so like something like related. So a rank of matrix is a number of places. So, for example, if you have like a matrix like this, for something like this, so you count the number of places, it's exactly the rank. Okay, it's called rank. And this thing is like independent of like how you try to grill or how you try to do the row operations. Okay, three variables. So here, the three variables are the like columns not grilled. Okay. So of course, like if you're grilled, then this you're not free. So that's why like the columns which are not grilled is called free variables. That's all. Okay. So you can see like the red one is the places, the blue one is the like free variables. So that the rank is three, and then you have like a three variables, and the number of number of free variables is the same as the dimension of the kernel, if you remember. So it's a small reminder. But like the kernel will be discussed later. Okay. Anyways, okay. So let's begin like another topic: coordinates and bases. Okay, so coordinates and bases, like these kind of things are like really weird. But like in fact, like if you're trying to think it as if you are like trying to move your character like on your computer game or like like on a map, then it's like pretty like easy instead of like thinking it mathematically. So for example, so you are starting here. So you are starting at the like origin. Okay, so what you can do is like you have two movements. You have first movement is like going to right, the second movement going upwards. Okay, so how can you go to the treasure? It's kind of easy, right? I mean, like what you're doing is like oh, you just go right, up, right, right, up. So like you are doing two times of this and three times of this. I just write in this way because like like you can like try to do right, up, or up, right. So you can like interchange the order. So like I write in with addition sign. Okay, but like this 2 and 3 is exactly the like the Cartesian coordinates we usually call it 2, 3, right? This coordinate 2, 3 is exactly correspond to the coefficient of the like movement, or how many times of E1 and E2 movements do you need to get to the treasure? Okay, so this is called like the coordinate. Okay, so like let's try to do like some definition. So let V be a space, let B be a set of movements. The coordinates is in fact like if you are seeing this and you're like feeling scared, you just treat as 2, 3. So you coordinates like 2, 3 such that you need like a two times of like a E1 and then three times of E2. So you're like adding them together. Okay. So here's the example. So for example, if you have a basis of this thing, so it looks very horrible, but it's just two movements. You remember they are just two movements. This is your treasure. These are your two movements. So you need to find how many number of each movements do you need to get to 5, 3. Okay? Since you know that you need 2 of the first movement and 3 of the second movement, the coordinates in B, so the coordinates in a basis is exactly 2, 3. Okay? So if you're trying to draw it out, If I try and draw it out, you see, like it's kind of obvious, right? I mean, like you have like E1 like just going to right, and E2 is going like upward and right. So to go upward, you can only use E2. So you better use E2 to get to the like correct height, and then you use E1 to get to your result. So that's why it's like a 2-3. Okay. By the way, like this 2-3 is in coordinates B, and it's not the same as this 2-3. So there was a 2-3 here, right? It's not the same as this because like the bases are different. Okay, but like there's a problem. I said, right? We mentioned like B is a nice set of movements, but what exactly means by nice, right? Like I mean, I didn't even tell you what is nice. So like we call the action is nice if there are like two different notions. The one of them is linear independence. Okay, so linear independence means that if you move, you leave. If you move, you leave. So for example, if you remember like the first example, we are having like the right and like upward, right? Right and upward. If you move, if you decide to move, then you leave. There's no way that you can do like zero, some movement of this and some movement to the right and some movement to the top, and suddenly you get back to the origin. That's impossible. In contrary, if you have like three movements, for example, like this, okay, we'll get back. So it's like kind of easy, right? For example, like if you are trying to go to right, like this, and go to top, and go to inverse order of this, then you get back to the base point. And that we mean, but it's not linear independence. We don't want something like this. I mean, if we leave, then we leave. There's no way you can like try to retract. I mean, like by the way, like I mean by leave is that like I don't mean like if you go right and then go up and then go left and then go bottom. Okay, because like if you're trying to write down this thing is like a E1 plus E2. Okay, E1 plus E2 minus E1 and minus E2, right? If you try to like plus E1 plus E2 minus E1 plus E2 equals 0, already equals 0, so that's okay. Okay? But like we don't want something like this, since like, this thing is E1, probably like it's E1 plus E2. I can't write it with my mouse. I don't know why. Like today the mouse is not working that well. Plus E2 minus E3. Okay, so this is different. Like because like now this thing is not 0. Like it doesn't look like 0. But you get back to the origin. So that's not good. We say like the left thing is independent, the right thing is not because you can find a loop. Spanning. Spanning is even easier. If every point on your map or on your space can be reached by your movement. For example, if I only give you a movement to the right, to the upwards, okay, I only give you E2, but I don't give you E1. How can you get here? You can't, right? You can't. So this is called not spanning. So spanning means that you want to have like some way, a way or another, so that you can like get to like every single point on the space. It's called spanning. So if you know what is linear independence and spanning are bases. It's the two things above. You can't go back to origin, and every single point can be reached. So this is not good and not good. Okay. So a basis is considered to be a good enough movement. Okay, good enough like a set of factors. Okay, and like what is good about basis is that you remember the coordinates, right? We mentioned about the coordinates of a point. The coordinates is unique. For each point, there is exactly one coordinate, and there's no other coordinates. Okay, so that's why we love it, or else we don't love it. We don't like it. Okay. Okay, so you know, like now you know how to understand what is spaces. Then let's talk about like a subspace image and kernel. So I know like it's like a bit difficult, but like how you should feel is like you should view like it as like you know like you have like some like a computer like things inside computer. So it's like something inside computer. You can see you can't leave it, right? You just can't leave it, and like There's no way that you can try to like leave, right? So it's the same thing. A subspace is like like if you are playing like things on your screen, then it shouldn't go outside your screen. Okay, so that's called subspace. Let me try to make it like better. So subspace is mean by subspace if you have like two factors like this, like if you have any factor, any two factor, if you add it up, it's still on the screen. If you have two things on the screen, okay, if you add them up, like add them up in some way, like this, it's still on the screen. You see, like the dots I'm drawing is like I want you to think it in real life, like your screen, okay? You see, like these kind of dots when I try to add to each other, it doesn't leave your screen because like everything is on the screen, okay? So it's called like subspace, okay? And you also want to have like your origin. The origin is inside, or else your character is already not inside. So like originally you should be like on the screen, okay? So like stay inside the screen, and then if you like try to like draw a line, like a very very long line, it's still like inside the screen. So that's called like the KA, okay? So it's called a subspace. Just imagine a subspace like a screen. So like then you if you want to check something is a subspace, you check it. You can't let it go away from the screen. So that's all. Okay. So like like there's another thing. There's another thing. So like the screen thing is like done. Okay. So you know that this is a subspace. It is already a subspace. But like in real life, I can't show you a 3D space. So in real life, it's 3D, right? So if you take a photo or if you are creating a game, you're in fact like changing a 3D into 2D, right? You're actually changing a 3D into 2D. So can we try to describe this kind of like a transformation? Sorry, I forgot. Okay. So if you're trying to do this kind of transformation, like if you're trying to do a 3D to 2D, so there's something like important. For example, you want to have that like the factors. So you have the factor addition, right? Remember? The factor in the image should be exactly the same, right? Or else like your addition is not hold, then it does not hold, then it doesn't make sense. Okay? So you want to have the addition is like a hold under like the transformation, and also the multiplication hold under the transformation. Okay? And so like the second point here is that like if you're trying to like okay, so sorry. Let me give you another like a concept. So you can see like for a 3D space, like let's try to do a 3D space. So here is the 3D space. You have like a mountain, okay? So it's 3D, okay? If you're trying to draw a map, so it becomes like a flat land, right? So it becomes 2D. And you see that the height is lost. There's no height notion here anymore, right? Height here is lost. And we'll explain about this like later, okay? And look at if you have this example in your mind, that image is exactly what I drew. Okay, the image is that like you have like a 3D thing, probably, and then you are like projecting it onto 2D. So how large will it be? So that's the point. So the image is like where the space that you would like to try to map is mapping to. Remember, you have like two spaces, right? So this space we just call it as original space, okay? This space I just call it as target space, okay? Image is in the target space because like you are like trying to measure where it maps to, okay? So it's on the target space. The kernel, however, is the opposite. So if you have the 3D, you remember the 3D example, you have a mountain, and then like something like this, and then you're drawing it onto a map. So we have 3D to 2D, right? I said about the height is lost. Height is lost. What I mean is like if you look at the origin here, originally it's like all the things passing through origin with the same, like with different height, but the same location, will map to the exact same point. What I mean is like, for example, if you're using Google Map and then you are inside like a shopping mall, then in fact your Google Map doesn't help you because like you don't know which level are you in. The Google Map doesn't tell you because the map is like consuming all the information about height. So the kernel is the information lost. Height is the kernel is the information lost. In particular, you look at what is get mapped to the origin, then you can see like what thing is lost. Okay, so it's kernel. So rank number theorem. Okay, so let's see. So now you have like a 3D space. If you are drawing a map, okay, then you are like in fact you are sacrificing one dimensional, right? And then you will have a two-dimensional map. Easy, right? If you have three-dimensional space though, three-dimensional space, but you want to like map it to a point, to a line, okay? Then what you should sacrifice? In fact, you need to sacrifice two dimensions, right? Because you need to have only one dimension here. So Rayman theorem is exactly this. So the dimension of the original space is same as the kernel plus the image. Okay. Remember, its original space is not relevant to the target space. Not relevant to the target space. Okay. Okay. So last part is the eigenvector eigenvalues. Okay. So eigenvector eigenvalues, they should give you like a general impression of how a linear transformation works. Okay. But like to me, like if you are trying to understand it in the first time, then I would just like tell you it's just a story of majors. So, what do you feel about majors? Like, what is like in your mind? Probably the gender is probably not good to say anything about gender, right? But like, you should have like skills, right? You know magic. There's a skill. So in this world, every mage is like there's only one exception. So almost all mages have only one skill. It's called like lambda. Okay, so this is the skill of the mages. I just call it V. Okay, so mages are always called V, and skills are always called lambda. Okay, so eigenvector and eigenspaces. Eigenvector and eigenvalues are just mages and skill. Majors and skill. So what is mean by skill? I didn't like I tell you. So for example, look at this. The mage V is changing the T in front into a 2. Right? The mage changed the T into a 2. And hence we say V is actually a mage because it is like capable to change a T, which is complicated, into a number 2. And the skill is called 2. Okay, it's the lambda, or the eigenvalue, or the eigenfactor, right? So eigenspaces is like something like which is like a more like like a difficult. So like eigenspaces is in fact all the majors. You just collect all the majors with a skill lambda. So for example, if you like collect all the majors with skill 2 together, then it becomes an eigenspace. And by the way, you need to add like a mage 0. By the way, like we didn't say like 0 is an eigenvector because 0 is too strong. 0 can turn like anything into anything. So it's like too good. But like in eigenspaces, we need to add a 0. Okay. So if you're like having like a matrix of like a 4, 3, the factors on x-axis except 0 are majors with skill 4. The axis on like factors on like a y-axis is like except the 0 is of is of skill 3. Okay, so lambda equals 4 and lambda equals 3. So the eigenspace 4 is exactly the x-axis and eigenspace 3 is exactly the y-axis. Okay, so it's like a easy to understand concept. Okay, So let's try to do some example. I want to show you how you should deal with all these kind of weird concept because I didn't tell you how you should make it into your real life. So for example, you're having this kind of a question. So this question is totally normal, right? It's totally normal in your exam. So how do we do it? So we should think. So now T is a world transformation with with a skill 6. So there's a skill 6. Skill 6 means that there is a mage with skill 6, right? Or else there's no skill. So if you have a mage with skill 6, what will happen? For example, if you have a mage V with skill 6, then what you do is you try to use this mage, try to do this thing to the new thing, to the t plus 2i. If you try to do it, then you will see it's split, right? And this, how to compute tv? V is a mage. It turns t into 6. And now that's why you know that it's 8. Okay? And since you know, you look at this thing, V is acting on the whole thing and turning into 8. Hence, it's a mage for this whole thing with skill 8. Or say V is an eigenvector with eigenvalue 8. Okay. Similarly, if you have t to the power of 6, what do? You use a V again. And every single time you have a t touching the V, you can change the t into 6. So after changing 6 times, you know that it's an eigenvalue is 6 to the power of 6, or the skill is 6 to the power of 6. So another question. So lambda is also a skill with a mage V. You already know that this. But you want to find a mage for this thing. It looks complicated because now if you're trying to do S inverse V, it doesn't work. Because this V does not touch the T. Mage only can transform the things they can touch. They can't touch, they can't change. So what should we do? So the point here is this S inverse is bad. So we want to add a S to just cancel this S inverse. Okay? So let's see what will happen. So if you are trying to do the SV as a mage, then what will happen is this. So you have an SV here, but this S will cancel out with this S, so that's why it becomes STV. But V is touching the T now. So it will use its magic to change it into lambda, which is the skill name. Skill name lambda. But this skill name lambda, because it's just a number, so you can pull it out. But now you look at the whole thing. Look at what we've done. This SV is same as this SV. You thought the S is gone. You thought the mage has died, but he or she doesn't. She's still living here, right here, and it changes the whole thing to lambda. So that's why SV is the mage, is the eigenvector of this thing with the skill or the eigenvalue lambda. Okay. So here is how you should view the mathematical terms, because you have many concepts and your brain is you can force your brain to memorize, but it's not necessary. You should try to find a way or another to make it more fun. So here's my presentation, and I hope you like it. Thank you very much.